the time has come. They have now officially released the Solana web3.js in version 2. Hello and welcome to another Solana tutorial. Today we're gonna have a look at the new web3.js, which is now officially released, which means Answer recommends that you use it now. I mean, my recommendation has been for a longer time that you start playing around with it, but now I can also recommend to you that for any application, use the new web3.js, or really use the web3.js, which is now in version 2.0. That's gonna be the web3.js from now on. And the old one is gonna get deprecated sooner or later, I suppose. I can't imagine that they support it parallel forever. So all new changes will just be made to the version 2. Which means you do want to change to version 2. And in order to make that transition a bit easier, I'm making this video. Because today we're gonna compare the old web3.js to the new web3.js with some example code of how to get from here to here. Which is gonna write a simple script and then translate it to the new web3.js. And that should get you covered for like 80% of use cases that you will have with the web3.js. Of course, I can't go through everything, but I want you to get the idea of what is different and how you need to think about the new web3.js in order for you to figure out where you can find the functionality that you're looking for. And I did make videos about that before. I'll put a playlist here of all the Solana web3.js stuff that I did. I went through the technical previews and then release candidate 1, 2, and 3. So I have made videos about this before. And the stuff I discussed in those videos is still true. But now that it's officially released, now you can be sure that when you use it, nothing is gonna unexpectedly change all of a sudden anymore. Of course, I'm not saying that version 2 will not change. Of course it will, but it will go through the process of, if there is a breaking change, first functionality will get deprecated, but will still be usable for a while before it's actually removed in a major version update. But that's a longer process, so you will have enough time to adapt to it. And the way it's set up, I don't think they need to change that much. They might add new functionality as it comes in, as new standards are developed and whatever, but I don't think that the core is gonna change much. And that's the advantage that we have now with the official release. It's not a preview anymore. This is the real thing that they actually want us to use. So let's actually use it. Let's go. Solana new web3.js. All videos of mine. Releases. There we go. Pre-release. Today we have dropped the release candidate label from the Solana web3.js version 2. We now recommend it for general use. There you go. They recommend it for general use. And that was 7th, 5 days ago. 5 days ago. Let's check this blog post. Now available, Solana JavaScript SDK 2.0. Developers from all across the industry gave the new library a workout, finding bugs and making suggestions as they went. Me too. I didn't get a shout out here, but me too. I did that too. The final release of 2.0.0 today is better for it. Bleeding edge. So we played on the bleeding edge and now the edge is not bleeding anymore. It's now nice and rounded or whatever. I don't know what I'm saying either, don't worry. So what has changed? Web3.js offers a new API for interacting with Solana and it's incompatible with version 1. We will delay making it the default. So you will need to port your software to the new version or log to version 1 explicitly. Here's what it does for now. If you install the web3.js, it installs version 1 and we can install it with version 2. And apparently December 16th is the date where they will switch. So when you then install the web3.js, it installs version 2. Also the latest will point to version 2. And to install version 1, you need to say this explicitly. Okay, clone the repository, then read and run the examples. Oh, there are examples. Maybe we want to do that. Oh, wait. I think we did look at that, did we not? I feel like I've been here. Okay, let's do the thing that I said I would be doing, which is creating a script. First in v1, where we install the Solana web3.js in version 1. And then we do the same thing, but at version 2. Oi, oi, oi. What are all those errors? That doesn't look good. Whatever. So let's create a script that does some basic things that we're used to with the old web3.js. So this is version 1. That should have stuff like the connection, key pair, pub key, you know, all those things that we're used to from the old web3.js. And I'll just go through an example from the top of my head. Because I've worked with this a bunch, I know stuff by heart, which is really sad because I will need to learn everything by heart again. But whatever. An async error function. This is nothing web3 specific, but it's just I need to run something. And we're going to start with simple things like how do you create an address? Like if you were to specify a receiver. We do that with new pub key and then we paste the address. Do I have an Andy address here? Ha! Just gonna take that. Whatever address. And then how do you create a key pair? A new random one like you would when you wanted to create a new mint. You say new key pair. And that's it. That generates a random key pair. Super simple in the old web3.js, right? A bit more complicated was how to read a key pair from file. Like if I want to specify my signer to be a key pair, I did from secret key and that took a uint8 array which I read from a file. So a new uint8 array, an array like, or an iterable of number. That's what I'm going to use, I guess. First I will read key pair bytes from file system. Since we do a node script, might as well install that. We read a file. So let's say we had a key pair somewhere. That's my key. Put that here to read the bytes, which is the buffer, just the bytes here. And that's how we read a key pair from file. Another use case that I have quite often. And then next thing would be creating a connection. New connection here, just say where. So the address of the RPC. Should I work localhost? So let's do, and we start a test validator at this port. And once we have that, then I would build a simple instruction, a transfer, and there I have the system program transfer that I can just call with the parameters from my signer pub key to my receiver, and then Lampert's, I don't know, 0.01 Lamperts per sol. So 0.01 sol times Lamperts per sol makes it Lamperts. Makes sense, right? Then I have a transfer instruction. And then maybe I want to do another more complicated instruction, like actually, I don't know, interacting with the token program, or even better, the new token program, TP22, to create a mint. How would that work? There I think I need to import something else. I think something SBL token. Yeah, add Solana SBL token. Gotta install that. And then in here, there's a token programs and stuff. And we are looking for a create mint. And because we want to do the instruction and not everything in one, this is the thing that will then already send me the transaction, which is not what I want. I want to just get the instruction. So I need to create initialize mint instruction. And there are two versions, and I guess I'll take the version 2. So I do that, which returns me a transaction instruction. That's exactly what I want. Perfect. So I just provide all the things. The mint pub key is from my new key pair. The pub key, the decimals, I'll stay with a default of 9. The mint authority, let's say, is my signer. Freeze authority, I don't want one. And then I want to do it with the token 2022 program. So that's the create mint instruction. And then I could add more, like, you know, this would then be the actual mint instruction, or call it mint tokens instruction, which create a mint to instruction where we mint to some account. Oh, actually, before we can do that though, we will need a create ATA instruction, create associated token account, who pays the associated token. That's the ATA. Oh, for that I need to get the ATA. How was that? Get associated token address for the mint and the signer pub key. And I don't care about that, but then for the token 2022 program. And then here I can provide the ATA, and then the signer shall be the owner, and then the mint is this, and then the program again, the token 2022. See, this is all like I'm used to that. I write that pretty quickly. So then we have the first finding a token, the token account address, and then creating those mint instructions. So here again, the mint pub key, the destination is the ATA, and the authority is my signer. And here we always just provide the public key. We always just provide the address, and then the actual signer we add later. That works differently in the new web3.js. Still need to say the amount, I don't know, mint me 1 token, but with 9 decimals. That's why I need to add this here. Okay, and then I want to do this transfer and the creating and minting of the token in one transaction. So I just say const transaction is a new transaction, which is in Solana Web 3, the old one. And then I can just add all of the instructions that I want to have here. My transfer instruction, my create mint instruction, my create ATA instruction, and my mint tokens instruction. Then I will need a block hash and a fee pair, which is relatively simple. You just set that signer pub key, and again we just provide the pub key, not the actual key pair. And then the block hash, this one we will now actually get from the RPC. So just call the connection get latest block hash, await this, and get the block hash. Boom. Set the block hash. Then we can sign this transaction, and here we then actually provide the signer. So this is my signer that will sign this transaction. And then we have a signed transaction, and we can just send it. Although before I send it, I want to simulate it, because that's something that I haven't figured out how to do in the new web3.js, and it's super easy in the old one. I just say connection, simulate transaction. I mean, okay, fair enough, it's deprecated, I should use a version transaction, but this entire thing is gonna be deprecated, so I'm not even gonna bother. Literally just gonna give you that transaction to simulate, and you will give me a simulation result. And then I will log this simulation just to see if we get any errors. I could also check if there are errors. And if there's not, then I'm gonna send that transaction. So here I simulate, and then I send again just with connection, or actually the easier way is send and confirm that transaction directly with a connection, the transaction, my signers. I mean, I have already signed it, but I'll provide it to you one more time. And I want a confirmed commitment or whatever. And then I await this and get the signature. I just log myself the signature. So that's a simple enough script. Let's see if I can run it and if it actually works. Okay, with TSX we can at least run it now, and we get a bad secret key size. Why? Oh, hehe. Oops, I need to parse this because that thing reads the bytes as string, of course. And then I'll put this as a number array. Yes, and the next error is the endpoint URL must start with HTTP or HTTPS. Sure. That better? Now we failed to get a recent block hash. So turns out even the old web3.js, it's not that, like, if I write it from my memory, I'm not doing that well, am I? Failed to get recent block hash. Oh, because my test validator died. That's why. There we go. Yeah, that's what I expect. That's the simulation, and we get an error, account not found, and that's why we stop. I return here because we have an error. Because that account doesn't exist. Well, okay, sure. Solana, airdrop, this account. 1,000 sol on local. So it's again the other way around. There you go. Now the account should exist. And if I run it again, there we go. Much better. Okay. Now I get a simulation of the transfer succeeds. The initialize mint doesn't, because Lampert balance below rent exempt, because what I'm forgetting is that the initialize mint requires me to also fund it myself, which, you know, really behind the scenes is all done if we would just do a create mint. This create account instruction. And I think if I create an associated token account, the associated token program does that for us, but here I need to do it manually. So I'm just going to borrow this. Create mint account instruction. Mint size we import. And from the get minimum balance for rent exemption for mint size. Oh, that already gives me promise for a number. Perfect. Or it could be that the new token program has bigger mint sizes. Let's just do it like that. That's okay. And then I add that here as well. Okay, that should hopefully fix it then. Yep, fixes that. But then we still get invalid account data for instruction when we mint 2. Invalid account data. Why? We did the initialize account v3. Oh, because we're now calling token keg. Whoops. That's why. When we mint 2, we of course also need to specify that we want the program. And see, that's a bit annoying. I need to specify this undefined here because that multi-signers was here first and then they added the program ID. So yeah, program ID B token 2022. And then hopefully the simulation should work. Yeah, simulation gives me success. But then when I try to send it, I get a signature verification fail where we miss a signature. Oh yeah, absolutely correct. I don't even need to sign here actually, but I leave it. However, I should also put the mint as a signer. And then do I need to put the mint here as well? I'm not sure. Yeah, I guess so. Because you re-sign it. Okay, and if I put it here, then there we go. Now it actually works. And we have this transaction. And we could confirm it here. Then we see what's happening. From our 1,000 sol, we've sent 0.01 to this account. And we created a bunch of other accounts. And now I have a token. Yeah, whatever. Okay, cool. Works. Only took me an hour, lol. And that's a simple script for the old web3.js, right? Nothing new here yet. This is how we used to do it. And now I want to translate this to the new web3.js. So that's why it actually gets interesting now, finally. It's a short script, but it does most of the things that you do. Interact with system program, token program, and simulating and sending transactions. Maybe creating an instruction manually, but I also did that previously. So yeah, it's fine. Okay, so let's do all of that in version 2. I'm going to copy that, create a script 2. So immediately we see that here we don't have all of that stuff. Transaction we have, yes, okay, but the rest we don't. And we also don't have Solana SBL token anymore, so we can get rid of that. So let's go through how to do those things, but with the new web3.js. We start easy, but it's not actually easy if you don't know how it's done. Wait, I'm gonna first comment all of that out. To create a new address, like this receiver, I said address because in the new web3.js it's literally called address. That's in the new web3.js and it works similarly. You just put that string here, boom, and you have that address. We're not working with objects anymore like here. In the new web3.js it's all functions. So also the address is a function, and this is the putative address, like the supposedly an address, but if it's not actually an address, then this thing will fail on me. Like, for instance, if I had a 0 in here and I would run this, then I will get this invalid value for this for base 58 alphabet because the 0 is not in my alphabet. And even if it was in my alphabet, if it was not a valid address, then it would also complain the actual length is too long. We expect between 32 because all ones, 32 ones is the system program, and 44, which is a regular pub key, and we provided 88. So it's not a valid range. And even if it is the valid range, but it starts with the wrong letter, then it should also fail on me because this is not in bytes the right length anymore. Expected base 58 encoded address to decode to a byte array of length 32, and the actual length is 33. There you go. Now the decoded byte array is even too long. So yeah, that address function checks for all of those things. It checks that it's an actual valid Solana public key. Cool. Good. Establish that. So that's step number 1. When we used to create a public key, we now have this function address instead. You can force use just strings without that address, but I recommend that you do that address because then it does the checks that is actually a valid address. You can just typecast it to an address and it will also work, but better use this function. Cool. Then how do we create a new key pair? Generate key pair signer, because with this guy we can then sign. Again, you just gotta know stuff. And again, we don't have objects, we have functions that give us what we want. Okay, how can we load the same key pair? Well, I'm just gonna uncomment this because this just reads the bytes. That's nothing web3.js specific. But then to make this signer, create key pair from bytes. And I can also do from private key bytes, then I just use the first 32 bytes. But from bytes, I use the entire 64 bytes private key and public key. We discussed this in a previous video somewhere. And the bytes is read-only uint8 array. So need to do this stuff again, I guess. Will this work? Yeah, but it uses an experimental feature. Fine, use an experimental feature. Okay, then the connection, also that works a bit differently. Again, we're not gonna do objects in the new web3.js or in web3.js version 2. We use get Solana, I don't know what it was called, but it's in this example. Create Solana RPC, that was it. Create Solana RPC, and then I provide the cluster URL because an RPC, that's the interface, and then the Solana RPC, that's a more specific interface. Here, do the same thing. Boom, chaka wawa. And then I have the RPC. However, here we distinguish between two different ones. The RPC, which is the HTTP connection where you actually, send your requests to. And then we have the RPC subscriptions, which is actually the WebSocket, which you use for confirming transactions. So when I want to use a WebSocket, I need to specifically also add the RPC subscriptions, which I do with this create Solana RPC subscriptions. Again, we always have this create because functional programming and not object-oriented programming, which makes this whole thing a bit more difficult to read. But yeah, we get an RPC subscriptions in the end. So far, so good with those things. We can't really do much yet, but we will use them later when we create a transaction sender, like we will do here. Again, this is not a function that is just available. We use a factory to create it, and this factory will take the RPC and the RPC subscriptions, and then we have the send and confirm transaction, which itself is a function that we can then call send and confirm transaction to actually send our fully signed transaction. But we're getting ahead of ourselves. Let's continue with a simple transfer. And here comes another change of the version 2. It's much more modular. So if you don't interact with the system program, you don't need to have the code in the web3.js that has all the system program functionality. We want to be lean. So they split it in different packages. Specifically, this one is Solana program system, I think. Let's check. We found the web3.js in version 2. And system program still has the dependency of release candidate 4. but release candidate 4 is pretty much the same as version 2. So I'm just gonna force you. That will get sorted, I hope, soon-ish. That all those dependencies will also take the version 2 and not the release candidate anymore. So yeah, let's just pretend that it's the same version, and then it will let me do that. And here I have all the system program stuff. The advanced nonce instruction. Get, where's the transfer? Transfer sol instruction. That's what I want. So this one, the equivalent for this transfer instruction would be to get transfer sol instruction, which takes this input, those configs. So input, the amount, destination, and source. Source will be my signer. Oh, I need to await this. Yeah. Signer, pub key. And here, hold on. Here, I would expect that it actually requires an extra signer as the source, because those instructions now also always store the actual signers and not just the addresses. It's just a different way how it's done. Crypto key pair is not assignable to transaction signer. Oh, we have a crypto key pair and I want an extra signer. Oh, damn it. So I need sorry, I lied to you. What do I need instead then? Create key pair signer from bytes. That was it. Then the destination, that can be just the address, I hope. So that we put our receiver. And then the amount, once again, 0.01. And here we don't use that times lamperts per sol anymore. Here we just say lamperts and then provide this big int. That would be for extra, if I put extra lamperts, but I don't put lamperts, I want to put sol. Well, how do I do that then? Since I don't see a lamperts per sol, so I'll just do 1, 2, 3, 1, 2, 3, 1, 2, 3. Make it a big int. Okay, fine. I'll just manually do it like this then, because I don't know how. There must be a better way than this, but I don't know. So for now, I'll do it like that. I would expect that there's a function called sol, but I didn't find it. And if I really wanted to do it like this, that I specify it like that, then I would need to be like, create a big int from, and that would also work. Okay, moving on. Getting an associated token account. That is token stuff. Where would we find that? Let me guess. It's in a different crate. Package. Not in Rust. I mean, I'm pretty sure they have the same convention. It's a Solana program and it's the token program. Token program. npm install this. Yeah, but we have the same issue again. Force it. Again, they will fix it eventually. And in here, we have get is associated token, find associated token PDA. That's the thing. Instead of get associated token address, we say find associated token PDA. Seeds being mint owner token program. Very nice. Mint being my mint address. Owner being my signer address. And token prong being the token 2022. What is it called here? Where do I find the program IDs here? We have the token program address, which is token keg. So is there a token 22 then? Nope, that does not exist. I find the token program address and I find the associated program address. Where's the 2022 then? And Solana program, what else is here? Memo stick. Token 2022. It's a separate one. It's minus 2022. Token minus 2022. Does that exist? Yes, and again, force it. Okay, again, I'm teaching you how to find those things. How did I do that? Well, a bit complicatedly. I found where it is, where the source code is, and then I just went through the repos, and here it is. You would also find, the stake program or the memo program in here, or the compute budget program in here, or the address lookup table program in here. They just go with the same naming convention. So token 2022 doesn't have the token program. It does have the find associated token PDA though. but it will have a token 2022 program address. Wonderful. Love it. So back to here, we can say that the token program be this, and then we've provided the first part, which is the seeds, and I can in the config as well provide the program address, but I don't need to, and I don't think I want to, so don't want to specify double. So I get a promise for a program derived address, await this, call it my ATA, which is now this read-only address and bump. So actually it's the ATA and the bump, not even gonna open. You know, if I wanted to, I can have the ATA bump, but I don't want to. And I also don't want to specify it like this, like I would do in Rust, to make it clear that I'm ignoring this, because that will make it an actual variable in TypeScript, and I don't want that. Just want to unpack it. Yes, learning TypeScript. That would actually be a good topic for a different video, just TypeScript basics. I'm gonna make that video. I'm gonna do another separate video on just TypeScript basics in case you're a bit confused by all those types. Good. Now that we have the address, we can now go and create the actual instructions like this. Let's go one by one. Create mint account, again from the system program. So it must be in here. Get create account instruction, which takes what? Lampert's new accounts payer program address space. So same as this, but different names. The from pub key is the payer. And here we don't just provide the public key, we provide the actual signer. This payer needs to be an actual key pair signer. Wait, hold on. It needs to be an actual transaction signer. For instance, a key pair signer like we have. Then the new account pub key is the new account. I called it mint, I think. That also needs to be a transaction signer. Then space, that stays the same. Do you also have such a convenient size? Yes, you have a function, get mint size. Convenient, because then I can specify the extensions. Get mint size without extensions. Then Lampert's is also again Lampert's. And here I would again need to call the RPC. And here I'm already stuck again because I don't know how to do that. RPC. Get minimum balance for rent exemption is directly in the RPC. Haha, wonderful, I take it. Get minimum balance for rent exemption with a size. And the size is this. Yes, I have duplicated code here, I don't care. Num is not assignable to big int. Freaking hell, get a big int then. Cool, gotta await this. Why? Oh, because I need to call send here. Ah yeah, there we go. That I then need to await, and that should then be fine, hopefully. And then the program address, that's the program ID here. So that's the program address that will then own the account, and that will again be my token 2022 program. Cool. So that is now that. Wonderful. Moving on to the create mint instruction. Which similar thing, but this time it's in the SBL token. Is that also called get create mint? Wait, what's it called? Initialize mint, right? Get initialize mint 2. Get an initialize mint 2 instruction with the following inputs. The mint be the mint, and it expects just an address. Okay, so here I would say mint.address. The decimals, I'll say 9. The mint authority is my signer. And this I think needs to be, no, also just an address. Okay. The freeze authority, oh, I don't need to provide it. I'm not going to provide it then. Okay. Cool. I mean, so far so good. That gives me initialize mint 2 instruction. It's so neatly typed. It's almost funny. Moving on. This is just a writing exercise. The create ATA instruction is then a get create associated token instruction, again with input parameters. What is the mint? The mint. What is the ATA? The ATA. What is the owner? The signer. What is the payer? Also the signer. And I think here it requires yep, this one needs the actual signer, so not just the address. Wonderful. And the system program, because this one, the create ATA instruction, if we call the associated token program, the associated token program actually creates the account. For the mint, we do it manually here, but for the associated token account, but that's actually a good point. Where do we find the system program address? Program, system program address. There we go. And the token program is the token 2022 program. There you go. Last but not least, the mint tokens instruction. Get a mint2. Oh, maybe we should do a mint2 checked. Let's do it checked. Again with inputs. Mint be the mint. Authority be my signer. Amount be 1 times 10 to the 9th. Decimal. Oh, yeah, decimals 9. It's a checked instruction. That's true. And token, hold on, what is this now? Token account to mint tokens 2. Okay, that's my ATA. There you go. So basically the same as I put in here, just with this neat little input that takes it all, such that the order doesn't matter, because here the order matters, here it doesn't. That's why this solution I think is nicer. We will need to always, say this is this, this is this, and so on, unless we name it the same. Then we have all of the instructions, and now we need to build the transaction, and that again works a bit weirdly, but you'll get used to it, because basically we do this pipe. We create our message by piping, which is a function in the web3.js. And first we say create a transaction message in version legacy. Yep, good old transaction. And that thing then becomes this transaction message, which I further append a transaction message instruction, or even instructions. And here just put the instructions. So as above, all of that stuff. Boom. Except expected 2 arguments. In the new web3.js, this is so much more difficult to read. Like, what's my input here? Oh, instructions. Hold on. So you take instructions and the transaction. Ah, that's an array. Okay. You take this as an array, all of those things, and then the transaction message. So that's what we had from here, which is first this. So moving on, that's the transaction message with instructions now. Then the next thing would be this, to add a fee payer. So that's done with transaction message fee payer, and I'll say as a signer directly. So I'll provide the signer, not just the address, my signer to this transaction message. That would be now this part. No, this is this. And then the block hash would be the next step. Transaction message, set transaction message lifetime using block hash. You get a block hash and the transaction. And the actual block hash we can again get from the RPC, which is similar to our connection. Get latest block hash. I can, have a commitment here, finalized. I like to use for block hashes. Then I need to again say send this, and then I need to say await this, and then I need to say from all of that give me the actual value block hash, because I'm just interested in the block hash. And it still doesn't like that, because what do I need to put in the block hash? This is so difficult to read. Block hash lifetime constraint. A read only something. Can you give me more details on the something? That's a bit annoying, I must admit. I'm always going here to check. So a block hash lifetime constraint. Oh, you need both the block hash and the last valid block height. Okay, so basically both of that then. Just the value. Boom, there you go. That was this. And then we have the transaction message. Now we can sign. Signed transaction is sign transaction message with signers, I guess. because I provide you the transaction message. That's what I call it, transaction message. Could also call it TXM, it doesn't matter. And the signers are already in there because I put them in here. This is an actual signer. It can then use this thing to sign. And also in the individual instructions, I always put the actual signers, and also the mint thing here, I put it as a signer when it's required to sign. And so when I call this function here, sign transaction with signers, that it already takes the signers that are stored in there. And then I get this signed transaction. Oh, and it's a promise, so I await. And then I have a fully signed transaction with a block hash lifetime. And that fully signed transaction, I can then already put in here to send it with commitment confirmed. Then it will also confirm it for me. And this returns me nothing. But if I await this, then if I get here, then I know it has been confirmed. And I will print the signature by saying sign transaction signatures 0. The way these signatures are stored are actual bytes. It's signature bytes. The signature bytes are uint8 array. Would need to first encode it to get it in a format that I like. It's 58 encode. And then I can print it because this thing doesn't give me the signature as we are expected to from this thing. Let's see, let's run this. Oop, and we get errors. Await can only be in an async function. Where do I have another? Oh, I can't await in a pipe. Oh, okay, I need to do that outside then. Const block hash out here. Boom. Now, there we go. We get a simulation, and that means that it's failing. Transaction simulation failed. Why? Invalid account data for instruction. Why? Token C is complaining. Invalid account data at the initialize mint. Does do the create mint account first? Maybe this gives me an error. We did do the create account before. What am I doing wrong? Who can spot it? I would have expected that it's the wrong address or something. Or not enough lamperts or something. I don't know. Invalid account data can just be anything. Okay. Let's just quickly log those two things to see if we get the right values. 166 bytes. And that's the size. Wait, hold on. That's the size of a token account in my head. But that's more than what I expect for a mint account. But maybe mints at token 2022 are also that size. That's 0.002 sol. What would be token size? Also 166? Are they the same? Oh man, I would like to get to the definition of this. Wait, in my version 1 script, the mint size is what? Layout.span, which is what? Wait, let's see what this is in the old one. Here it's 82 and 146. There you go, that's what I would expect. That's the size of mint accounts, at least with the old token program. But here we're also using token we're using token 22 here as well. And it works with token Z. So did we find a bug here? Is this get mint size just bugging on me? I don't have the implementation, so I can't tell. Token 2022, program, scripts, clients, where would I go? Ah, mint base size is also 82. And then mint base size plus encoder extensions length. That seems alright, that implementation. Maybe something went wrong when I force built this whole thing. Ugh. That's not a good sign. Because if extensions is null, then mint base size, wait, should I say null here? Undefined, whatever. Then it's 82. Ahaha! So I cannot have an empty array. If I have an empty array, then it adds stuff. Okay. Need to do undefined. Sure. There you go, undefined. Then the required rent will be 1.4. That's more what I would expect from a mint account. And then if I have that here as well, then it will also, then we're below rent exempt threshold though. Because here I'm using, I should not, damn it. Okay, hold on. Required space is this, required space here. and no more freaking double calling this. So that's, now we shouldn't get that. And we get some other error. Unexpected uint8 array. Ah, the encode. Okay, so we did get all the way down here to the encoding, which expects something else. It expected a uint8 array, but it means that it's actually sending that transaction. Ah, there's a get signature from transaction. Let's do this. Let's do a get signature from transaction, which is in web3.js. Wonderful, don't need to do that manually. From a signed transaction. And that is in which format? Signature, which is a base58 encoded signature. Yeah, let's do that. And get rid of my logging as well. Ah, there we go, much better. No more logging, who needs that? That's how you do it, much cleaner. And then we have such a signature, wonderful, and we can check that it actually does the same thing. Solana, confirm this. And we see we get success with the token program for all the instructions. First we did our transfer, then we did the initialize mint, then we created a token account, initialize account 3, and then we mint to checked. Cool, all of that worked, and we sent that transaction. We see that this account, the account 2, my key, no wait, my Andy should get that. The receiver should be Andy. Oh, there, account 2 is Andy. Oh yeah, there we go. So we see that account 2 has from 0.7 to 0.8. So another 0.01 sol we transferred. Nice. So the script basically does the same thing as in version 1, except we don't simulate yet. And that's one of the things that I don't know how to do actually, and that for some reason is really difficult for me to figure out how to do. I spent hours on this and then I gave up, but it can't be so hard. So today we gotta figure out how to actually also simulate transactions. Because I mean, it's nice that we can send them, but you know, I don't want to have to confirm them manually, and I would like to have a simulation. I sometimes just want the simulation and not the actual sending. So I need to figure out how that works in the new web3.js. Can't be so difficult. And once I know it once, I'm gonna know it. Although, is that true? I think I did it once and then I forgot about it again. So how would I figure this out? RPC, do you have a simulate? Yeah, it has. Maybe I just really didn't find that at all. Take a base 58 encoded wire transaction. Can I give you my signed transaction? And then for config, oh yeah, that was the thing with the encoding, I remember, where you need to force tell that the encoding is base 58 or something like that. Oh, base 64 encoded wire transaction. There was something with a transaction encoder, right? Yeah, get transaction encoder. You give me a read-only uint8 array. Okay, wait, that's a transaction encoder. Hold on, no, I can't put that in here yet. What is this? How do I get this? Get base 64 encoded wire transaction from a transaction. Oh, why not use this in Solana web3.js? Yeah, wonderful. From a signed transaction, can I do that? Wonderful, I just take this, put it here. Forget all of that. Oh, and you expect 64, of course. There you go. Haha, that looks good. It's a one-liner, not that difficult. Simulation is this, and console log my simulation. Let's see if it also comes with the same, what is the type here? Oh, it's a pending RPC request. How about we actually send it? Boom, boom. And then we get what? A promise for context and value. Okay, and then we await this. And then we hopefully have the same thing here. Yep, value which has error, a transaction error or null. Haha. And if it has an error, then we return, and otherwise we send it. Cool. Let's do this. Do we get a simulation? We do get a simulation, and we see it's successful. Nice. And then it actually sends the transaction. Nice. That's how you simulate. Wonderful. I figured it out again. It's actually quite easy. It's just in the RPC.simulate transaction. You just got to get used to that. It's not actually that difficult. And you just got to find all of those functions that do the things that you need to do. And you figure that out basically by, you know, reading a bit of the source. Yeah. Cool. And that's that. So now we know how to create addresses, how to generate key pairs, how to read key pairs from a file, how to create a connection, specify where to find the RPC. And that works, for, we don't need to go localhost. We can also go to the regular devnet RPC, and that should also work. Nope, it doesn't, because we ain't got no sol there. Airdrop me a sol to, what was my address? This guy. But then it should work. There you go. Simulation works. Now we're waiting for confirmation. Confirmation is here. That's the transaction. And check it out. Check it out now. The funk soul brother. We created a token mint, transferred 0.01 Lamperts to Andy, created a token account, and minted 1 token into this token account. All in one transaction. With the new web3.js, the web3.js in version 2. Nice. So we know how to specify connections, that's where I was. We know how to create instructions to the system program, find the ATAs, create instructions to the token program, get and set block hashes, create a transaction, append the instructions, set fee pair and block hash, simulate transactions, and then actually send transactions. And that should have you covered for most use cases for scripts with the web3.js. Boom. Then there's this whole other topic with working with the web3.js for the browser, like as a web extension, which I will keep as the topic for another video. Also topic for another video, TypeScript basics. I want to do a separate video just on the basics for you to better understand how TypeScript actually works, such that you're not so confused when you read all of that. And I will put that video right here. Here's another one that YouTube recommends for you. Give this one a like, subscribe if you haven't already, and then I will see you in one of my next videos about the new web3.js, which is the web3.js from now on. And yeah, in the future I will just use that one. I have been for a while, but now especially. Yeah, what else do you need to say? Thanks for watching. I also make videos about other things, not just the web3.js, by the way. Enjoy those, and you'll see me where you decide to see me. Till then, bye-bye. And enjoy working with the new web3.js. Because if you ever worked with the web3.js, or you ever intend to do it again, you probably want to use version 2 from now on. Okay, bye!